Alright guys, welcome to the mathematics lesson. This is the mathematics lesson 14. In today's lesson, we'll be looking at the geometric progressions. So we will be looking at the geometric progression. So without wasting much of your time, what is geometric progressions? We are saying a geometric progression is a sequence in which each term is formed by multiplying the previous term by a constant amount. So you have heard it that a geometric progression is a sequence in which each term is formed by multiplying the previous term by a constant value. For example, let's say we have this as a geometric progression where we have 1, 2, 4, 8, 16. So for this one to qualify as a geometric progression, unless the next term must be found by multiplying a constant amount to the previous term. So is it true that this one is a geometric progression? Yeah, it can be true. For instance, for us to move from 1 to 2, unless we multiply 1 by 2 for us to move to 2. Again, for us to move from 2 to 4, unless we multiply 2 by 2 again. Again, for us to move from 4 to 8, we must multiply 4 by 2. Again, for us to move from 8 to 16, we must multiply 8 by 2. Similarly, this other geometric progression here, we can notice that for us to move from 4 to 12, we must multiply 4 by 3. Again, for us to move from 12 to 36, we must multiply 12 by 3. Again, for us to move from 36 to 108, we must multiply 36 by 3. Equally, this arithmetic progression also here, for us to move from 5 over 6 to 1, again from 1 to 6 over 5, unless we multiply 5 over 6 by 6 over 5 for us to go to 1. Again, for us to move from 1 to 6 over 5, unless we multiply 1 by 6 over 5. So we are saying that this constant amount is called the common ratio, and it is represented by letter R. So this constant amount here, 2, 2, 2 in this one, 3, 3 in this one, here 6 over 5, then this is a constant amount, and this constant amount is called the common ratio, and it is represented by letter R. Alright, so let us look at finding the nth term of a geometric progression. Finding the nth term of a geometric progression. So we are saying if we know the first term of a geometric progression and the common ratio, we can use them to find the other terms of a geometric progression. So we are saying here that if we know two things of a geometric progression, one, the first term in a geometric progression, and then the common ratio in the geometric term progression, then using these two, we can find the nth term or any other term of this particular arithmetic progression. So we are saying, let's say the first term is A and the common ratio is R. We can come up with a geometric progression as shown below. So A is the first term and R is the common ratio. Using these two, we can come up with a geometric progression as shown. So the first term can be A, because we are saying in this geometric progression, if the first term is A, then we can write A as the first term. Then for us to get the second term, since we are dealing with a geometric progression, we must multiply this same first term by the common ratio, which is R. Alright, again, for us to move from this second term to another term, we must multiply this term here now by R again. Alright, again, for us to move from this third term to the fourth term, this is the third term, right? So for us to move from this third term, which is here, we must multiply by R. So, and so forth and so on. Alright, so now if we are to simplify this here, this can remain as A, then this one can remain as AR, then this one can be A, then R times R, which will be r squared. All right, then this one can be a as usual. Then r times r times r, it can be r to power 3, and so forth and so on. And you'd realize that this a here is known as the first term, and then this ar is now the second term, and then this ar squared is the third term, and then this ar cubed is the fourth term, and so forth and so on. Now if we want to find now the nth term, all right, the nth term. So what is the nth term? So the nth term is any term of a geometric progression that we can find. So that is occupying the position nth. For example, here when we say term 4, meaning that this term actually, the actual term is this one, but this term is occupying position number 4. So here also the term, we want to know the actual term, that if a term is occupying position any position, it can be 2, 3, 4, whatever it is. So this n represents for any position, then that particular arithmetic, geometric progression term can be found as shown. So you can create a relationship when you look at the term, the position of the term and the power of r. There is a relationship. You see that there's a difference of 1 between the position of the term and the power of r. So here also, if the position of the term is nth, then there must be difference between r here. So we will say then that the formula for finding the nth term of a geometric progression will be a times now r. So now you realize the difference between the power here should be 1. So it is as good as saying n minus 1, because the difference between 4 and 3 here, it is 4 minus 1, which will give us 3 here. Equally here, for us to get the nth term here, or the power of r here, we must get n minus 1. Hence what we are saying is that the nth term of a geometric progression can be found by now ar, then n minus 1. So ar to power n minus 1. So this one is now the formula for finding the nth term of a geometric progression. All right, so now we are saying, and the common ratio r of a geometric progression can be found as shown. So the common ratio, this r here, can be found as shown, where you get r must be equal to, you get the second term divided by the first term. So if we get the second term divided by the second term, the first term, we can get the common ratio. So for instance here, what we are trying to mean here is this. So what we are trying to mean is this. If we go in our previous arithmetic progression, geometric progression, where we had 1, then we had also 2, then we had 4, then we had 8. So we said the common ratio was actually here 2, even here 2, even here 2. So for you to know this one, it is simple. If you get the second term, for instance 2 divided by the first term, which is 1. When you divide this one, you get what? 2, which is the common ratio. Equally, if I get 4 divided by 2, I say 4 divided by 2, I'll still get what? 2 as the common ratio. So this is why we are saying that if you want to find the common ratio, we just get the second term divided by the first term, or which is the same as the third term divided by the second term. All right, so either this one or this one can be used to find the common ratio. All right, so we are saying that then the common ratio now can be given by r is equal to t, then we say n over then t minus n minus 1. All right, so again, you notice a relationship between this and this. So if this is n, then this one should be n minus 1. That's the whole idea here, guys. All right, so now let's move a little bit and see some examples. So let's look at example here. So in this example, we are told 1, for each of the following GPs, geometric progressions, find a formula for finding the nth term. So we have A, 4, 12, 36, 108, and B, we have, 256, 128, 64, 34. Then at 2, if x minus 2 comma x and x plus 3 are the first three terms of a geometric progression, then they say find A, the value of x, then B, the value of r, then 3, the fifth term and the eighth terms of a geometric progression. The fifth term and 80 terms of a geometric progression are 80 and 640 respectively. Then they're saying A, find the values of R and A, then B, write down the first terms of the geometric progressions. All right, so these are examples that we are going to answer to give you, to show you how to answer questions coming from geometric progression. So let's begin with the question number 1 right away. All right, so now this is question number 1. So we are going to say solutions here. So in this question, it is important to understand what you are trying to find here so that everything is clear for you. So they're saying for each of the following geometric progressions, find a formula for finding the nth term. So the nth term. So we have already established the formula for finding the nth term, which is Tn is equal to Arn minus 1. All right, so this is the formula for finding the nth term. So we need to establish what is A. So A is the first term, which is 4. That's what we said, remember previously. Then now we need to find the R. R, we said, can be found by T2 divided by T1. So in this case, we can just say R is equal to, either we get 12 divided by 4 here, which will give us R is equal to 3. All right, so we know now. So we'll say now R is equal to 3. So it is important to put your information like this so that you are clear about what you're about to do. Then you substitute, you say Tn now is equal to A is equal to 3, then A is equal to 4, then times R is equal to 3, then this 3 must be powered to the power n minus 1. So remember, we don't know n here, so we are just finding the formula for the nth term in this one. Then we are going to say Tn is equal to, now then what we are going to do is to remove this multiplication and put this one in the brackets, then to power n minus 1. So you shouldn't multiply 4 with 3, because doing so is going to result into finding a wrong answer, because this one is a different power, this one is a different power. All right, so in multiplication, if you find you want to multiply unless the powers are the same, so if the powers are the same, then you just multiply the bases, something like that. All right, so this is the formula. So let's look at the number 2 again. So we are going to remain with the formula for finding B here. Again, here we should determine what A is. So A is the first term, which is 256 here. All right, then now we are supposed to find the R again. So R again is equal to the second term over the first term. So this one by this one, or this one by this one. So which will be R is equal to, we'll get 128 divided by 256. So you realize that if we divide 128 into 128, 1, then 128 into 256, which will be 2. So R is going to be 1 over 2. So knowing these values, now we are going to substitute, where we are going to say that Tn is equal to, where there's A, we put 256, then we are going to say times. So where there's R, we are going to say in brackets now half, then to power n minus 1. All right. So now what we are going to say is Tn is equal to 256 times. So this one here, it is the same as being written like this, 2 to power negative 1. This is what this one can go to. So if you can't see properly here, maybe you need to, if you can't understand, I mean, you need to watch a video which I did on the laws of indices that will pop up here. Right, then to the power now n minus 1. So you're going to say Tn is equal to then 256 here, then times, then this one now you are going to clear out this power and this power here. All right, so what you are going to do is to say it will be now 2 to power negative n plus 1 plus 1. So what I did here is to multiply negative 1 times n, which will be negative 1. Then in negative 1 times negative 1, which will be positive 1. So maintaining the same power. Then from here you say Tn, then now what you are going to do here, it is also to write this one as a power. So you realize that this one also can be written as a power of the base of 2 as the 2 to power 8. Then you say times, then 2 negative n plus 1. In case maybe you are doubting, so let me just show you here is that if you have 2 to power actually 8 here, it is going to give you still 256. All right, so this is this and this are the same. Then let's push this one up here. Then now what you are going to do next is to make sure that you get the same base. So Tn is equal to, so since the bases are the same, then you should add the power. So you write this, it will be like this. So the bases are the same, then you add the power. So what I did was to say 2, I just wrote 2, then I got these powers to add them. So what I did before I add, I put them to 2. I got 8 here, this is 8, then minus this is n. Okay, sorry, this one, why is it behaving like this? So I'm saying that I got the powers first. This 6, 8 here, 8 plus I added the power. That's the rule. If the bases are the same, add the power. So I added this plus open brackets. I add this one minus n, then plus what? Plus 1. So that's what I did here. Then I said 8. Then I said plus minus minus here, it will be minus n, then plus times plus, it will be plus 1. This is why I got, now I put now to power 2 so that I get Tn is equal to 2 power 8 minus n plus 1. So this is what I got here. Then from here now you say Tn is equal to, now you are now going to look at the 8 and 1, which are like them. So you add 8 and 1, which will give you what? 9. So you have 2 to power 9 minus 1 as your formula. All right, so let's go back and look at another question, question number 2. So question number 2 here says if x minus 2 comma x and x plus 3 are the first 3 terms of a GP, find A, the value of x, and B, the value of R. So what I'm going to do is to push this one up here and say solutions. So what they're trying us to find here, guys, is that they want us to find the value of what? X here. For instance, let's start with A. Now notice that it is quite tricky to find the value of x, but not really tricky. When you see the secret in this, then it will be so simple for you to find. So you have only been given the unknown variable like x. So how will you know x? So you must use the common ratio, because if you get this divided by this is the same as this divided by this. So you say the common ratio here is equal to, say t T2, we said T2 over T1, then we said it is the same as T3 over T2. That's what we said. So then realize, or banking on this one, we can say R is equal to, then let's say in this one T2 now is what is this one here, where we are saying X over T1 is X minus 2, then equals, then T3 we can say it is this X plus 3, then over, then T2 is going to be X. So now we realize that this and this are actually equal. So if this one and this one they are equal, then we are going to multiply. So we are going to equate this one to this one, they are equal. Then we are going to multiply x times x here to get rid of the fraction, which will be x squared. Then we'll say equals, then we'll multiply this times this, which will be this in brackets, then it times that in brackets as well. Then this means you multiply this bracket with this. So to make it simple, what I do is to break it down. So it means x times the whole of this one. So x times what is in this bracket. So I'll put like this. Then I'll say negative 2 again times everything in the bracket here, which is like that. Then I'll say x to power 2 now is equal to, I'll multiply x times x squared, so that I get rid of the brackets. Then x times positive 3, which will be positive 3x. Then here I'll say negative 2 times x, it will be negative 2x. Then negative 2 times 3, which will be negative 6. All right, so because of space, let's move here. So now we are going to now make x the subject of the formula. So they will cross all the x's on the right side of the equal sign, or on the left side of the equal sign. So we'll have x. Then now this one, when it crosses, it becomes minus x. This one again, when it crosses, it becomes minus 3x. Then this one, when it crosses, it becomes positive 2x. Then equals, then we'll remain with just 6 here. Then you realize x squared minus x squared is 0. So we'll not remind about it. It has cancelled itself here. Then we'll remain with 3x plus 2x. So 3x plus 2x. Since the signs are opposite, it means subtract the bigger number. Subtract this. Since the signs are different, it means you are going to subtract the smaller number from the bigger number. In this case, we are going to say 3x minus 2x, because the signs are different. So whenever the signs are different, then you are performing a minus, right, or subtraction. That's how it is. All right. Yeah, so whenever the signs are different, it means we are performing a subtraction. So you say 3x minus 2x, which will be x. Now, since the bigger number has got a sign of negative, even x will be negative. X equals negative 6. Now, for you to get rid of the negative, you multiply here by negative. So negative times negative, it will be positive x. Then negative times negative, positive 6. So x is a 6. We have found x is 6. Now let's find the value of r. All right, so now what we are going to do to find the value of r is the same. We'll say r is equal to now t2 over t1. So we'll say, okay, r is equal to x t1, t2 will be x over now t1 is x minus 2. Then we'll say r is equal to x, we have already found it to be 6, over here again x is 6 minus 2. Then we'll say r is equal to now this one 6 over 6 minus 2, which is 4. Let's push it here. So this one is as good as r is equal to then we'll say 2 into 6 3, 2 into 4 2. So this one will be the value of r. So let's go to another question. So question 3, they're saying the 5th term and the 8th terms of a GP are 80 and 640 respectively. So A, find the values of R and D. A, then B, write down the first terms of the GP. All right, so let's push this one up here and begin right away solutions. So what it is here, guys, is that they want us to find the values of R and A. So the values of R and A can be found. A is the first term and R is the common difference. Now, when you check in this question, they're saying the fifth term and the 80th terms. So these terms are the fifth term and the 80th terms of a GP are 80 and 640 respectively. So which means when they say respectively, it means the 80th, the 50th term is 80 and then the 80th term is 640. So notice that these are actually not consecutive. So 80 and 640, they are not consecutive or following one another, because the other one, 80, is at position 5. So this term is occupying position 5. That's why it is called the fifth term, and the 640 is occupying position 8. So that's why it is called the 80th term. So they are not following each other. So it will not be easy for us to find the common ratio. So common ratio, unless they are following each other. Then again, 80 is not even the first term. So it will not be direct. So we are going to get our own formula. Tn is equal to AR n minus 1. Then what is possible here now to use is to know that what we have been given is the nth term. N is equal to 5. Then what we have been given is the nth term, which is 80. So now we know that the nth term is 80. So we'll say T now here, it will be now 80 is equal to now A R, then N, it is 5. So 5 minus 1. All right. So we know this one now, it is this one. Now I'm going to say 80 is equal to AR, then we'll say 5 minus 1, which is 4. So we will call this one equation number 1, because we can no longer find AR as being asked here. So unless again we get this other term and say also that N is equal to 8, then T 80 is equal to 640, meaning that the actual value at position number 8 is actually 600 and what? And 40. All right. So that is the situation here, guys. All right. So you don't need to worry much, because this is not so much difficult. All right. So now, using the same formula here, what we are going to do again here is to say that now we have been given that on this position here, the actual value on the nth term or 80th term is 640 is equal to, then we'll say AR, then RN here is actually 8 minus 1, which will be 640 is equal to AR, then we'll say now 8 minus 1, which will be 7. Then we'll call this one equation number 2. So now the secret part here is to get equation 1 and equation 2, divide them. So when you divide them, since this is equal to this, when you divide this by 80, so this one by is equal to this one, I mean, all right, then here we divide by 80 and also here by AR4. So the question is, why are we dividing? So that we cancel AA. All right. So now, is it really making sense that we are dividing? Yes, it is making sense. Since 80 is also AR4. So if we get 80, we divide on this side we divide by AR, we are not altering this equation. It is just the same, because we are using the same value dividing on the same side of the equals or of the equal sign. So that's why it is just okay that way. So now A and A will cancel. Then we'll say here 0 will cancel. 8 into 64, it will be 8. So again will be equal to, so here will remain with R 7 minus 4. So here it is when you have R7 minus R4, because this and this will cancel, remain with this. This, according to the laws of indices, as good as getting R, then you get 7 minus 4. That's what we did. These are the laws of indices. I already told you the video that you should do. Watch. All right, then we are going to say R8 is equal to, then R is 7 minus 3, 4, which is 3. Then this one simply means the cube root of R. So here, if you find the cube root and here cube root, you find that R is equal to 3. So meaning R is equal to 3. Now we have found the R. So we can now find what? A. So R is equal to 2, So now we can find what? A. So now we can say in this formula, we can either get this one or get this one. It doesn't matter. So we'll say 80 is equal to A. We don't know. Where there's R, we put it 2 to power 4. Then we'll say 80 is equal to, then you realize that 2 to power 4, which is 16, 16 times A, 16A. Then what we are going to do is to divide by 16, divide by 16, so that you remain with A. So A is now going to be 5. So guys, this is what I prepared. So you are going to finish answering question number B here. All right, as for now, bye and see you in the next lesson, and please, peace.